Miss Harder! Remember that time you threw my Starbucks on the ground? Miss Zekman threw my Starbucks on the ground just before we came out here. She's bad mentee.
Hello, Room 9. Miss Zekman here.
This is Miss Harder.
And we are going to do some classroom chemistry. But before we do science, first we need safety. Alright, first thing about science is safety. So I have my lab coat. Still fits.
Why do you need to wear a lab coat, Miss Zekman?
Because science is all about safety and I need to keep safe if anything splashes on me.
Oh.
And I have my goggles because my eyes are super special and I want to protect those.
I'm not wearing a lab coat or special glasses.
The science do, the science don't. Don't be like Miss Harder and not have safety on.
Do be like Miss Harder because it's very cool.
Alright, we are going to talk about chemistry. Do you know what chemistry is?
No, Miss Zekman, please tell me.
It is the study of matter.
What's matter?
Nothing. What's the matter with you? No, matter is what makes up everything. So this cart, Miss Harder, this balloon is all made up of matter.
Okay, excellent.
So matter is like particles, very tiny, 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 that you can't even see them. And then matter.
What are those tiny particles called?
Atoms.
Do you want to hear a fun joke, Miss Zekman?
Always.
Can you trust an atom?
Yes.
No, because they make up everything.
Yes, so everything is made up of atoms. All right, we are going to talk about the 3 states of matter. The first state is solid. So I have some ice here. So a solid has a definite mass and shape. So Miss Harder, can you hold on to this ice for me?
Yes, this solid.
Yes. So all the atoms in this solid are quite packed and they don't move around a lot. They're not very social distancing.
No,
so
they wiggle like this. They just wiggle.
All right. Now, when I have liquid, that is our second state, it also has atoms. Now these atoms move around a little more.
Yeah.
But it does have a definite mass, but not a definite shape. So if I put it in this bowl,
and all over the cart.
My water still has the same mass, but it has a different shape. The shape changes as the container changes. Now my third state of matter is a gas. So the atoms in a gas are like, woo! They move around tons. So my gas does not have a definite mass or shape. It is always changing. Okay, keep holding on to it.
Okay.
So you think, wow, how does a gas have mass? Well, gas does have mass. It does have a weight. So this has my breath in it, which is carbon dioxide. And right in the air is mostly made of nitrogen and oxygen. If I drop my carbon dioxide, it goes down because carbon dioxide weighs less than oxygen and nitrogen. Now I have my helium balloon. Helium is a gas. Helium actually weighs less than nitrogen and oxygen. So because it weighs less than the air, it floats. Ooh.
Science.
Oh, there's the balloon. Don't worry, we will collect the balloon. Now, you may ask, but Ms. Zekman, can these states change? Why, yes. Yes, they can. Ms. Harder, how is our solid doing?
It's turning into a liquid.
Oh, and that's what we call melting. When my ice turns to a water, that is melting. When my liquid turns to a gas, that is evaporation.
What's it called when you go backwards?
Oh, when it goes from a gas to a liquid, that's condensation.
Yeah.
And when I go from a liquid to a solid, that's
frozening.
freezing. So there are 2 different types. There's a chemical change and a physical change. So when it can change back and forth, that is a physical change. So the substance stays the same even though the state changes. But a chemical change is when not only the substance changes, but also the properties.
Ms. Zekman,
Yes, Ms. Harder.
what would it be called when water turns into a gas? Where would kids see that in their house? Where could they see water turning into a gas?
Well, if you put a kettle on the stove and it evaporates and it goes,
So like the steam out of a pot or a kettle.
yes.
There you go. Don't touch steam, it's hot.
Or you can see condensation, a gas turning into a liquid when you take a really hot shower or hot bath and there's steam all over the mirror, that's condensation. So there's water vapor in the air, and it gets so hot that then they turn into a liquid, or when it rains.
Nice.
All right, now we're gonna test out different substances.
How long do I have to hold this?
Oh, we're done now. You can get rid of that. All right, we are going to talk about acids and base.
Woo! I like it.
So any sort of liquid is either defined as acidic or basic, and there's a scale. So the scale goes from 0 all the way to 14. The closer it is to 0, the more acidic it is, and the closer to 14, the more basic it is. So that means 7 right in the middle is a neutral. So we're going to test some things out here. All right, Ms. Harder,
Bleach.
what are some examples of acids that our students would have in the household?
Any kind of vinegar. Dish soap is a little bit acidic sometimes.
Ooh, lemon.
Lemon. Anything that you eat that is sour tasting is acidic.
And what about basic? What other basic stuff are there?
Miss Harder with her Starbucks. No. Okay, what are some basic things? If you have bleach at your house, that is basic. But don't eat bleach because you'll die. Baking soda and baking powder are both basic.
And my favorite, milk.
Your favorite milk? Okay.
Yes.
Also, anything you taste that is like bitter is basic.
So we have what's called litmus paper. So it's yellow, and you dip it into different liquids, and it tells you what the pH level is. So it tells you whether it's acidic or it's basic. So depending on what color it changes. So anything that's red is a 1, so that means it's very acidic. And as it gets farther away from the color red, it turns to a lime green color, which is neutral, so that's a 7. And then it gets all the way to the dark blue, and that's 14, which is basic. So we're gonna test out some things.
So grade 5s, anything that's a 1 or a 14 usually are things that you should wear gloves when you handle, and you probably shouldn't have them in a closed space. They're very, very damaging to your skin, and if you ingest them, they can wreck your internal organs.
Yeah, don't do that.
Don't do that.
All right, we are going to try some pure white vinegar. Oh, Miss Harder, what color does that look like to you?
Very reddy orange.
Oh, it looks like a 2 or a 3, so that's
Ooh.
very acidic.
Miss Eggman, have you ever eaten vinegar?
I actually don't like vinegar.
I don't either, but it's very sour.
Yes, I don't like salt and vinegar chips.
Me neither. I think they're gross. Waste of chips.
I'm a ketchup chip person.
Ooh, onion and sour cream.
Yes. Okay, now we are going to test the water that has baking soda in it. Oh, this one is green.
Ooh, yeah, it's very green.
This one is looking like a level 8. So it's almost neutral, but it's more on the basic side. And now we are going to test water. Ms. Harder, what do you think water is going to be?
I think it's going to be in the middle because water has no taste when you drink it.
Well, the sheet of paper barely changed color. It changed a little bit darker, and it's right at number 7. So water is neutral.
Woohoo!
Miss Harder, this
Yes.
pH color I have, pH paper, is yellow. But I also have a blue and a red one. What are the blue and the red one for?
So Ms. Zeckman, when you're doing a lot of tests and you just need to find out if something is an acid or a base, you would test with one of each of these papers. If the red one stays red and the blue one turns red, you have an acid. If the blue one stays blue and the red one turns blue, you have a base. The one that you started with is a universal indicator, meaning it'll give you the actual pH. These will not. These will just tell you if it is an acid or a base. When your grade 5s get to grade 7 and 8, they're going to use this paper all the time.
Yes, you can use your litmus.
Yep.
Miss Harder,
What up?
did you know I have a degree in science?
Could have fooled me.
Very funny, Miss Harder. I actually love science. I have a major in biology. Biology is the study of all living things. Whereas
I have a
chemistry-
minor in biology.
Science! Science! So if you like science, you should definitely do science if you think about it in university.
Agreed.
Do you know who Marie Curie is?
I do. She's a wonderful lady who won a Nobel Prize.
Yes, she is the first woman to win a Nobel Prize, and she actually won it in chemistry, and she is the first person and only person to win 2 Nobel Prizes.
Ms. Zeckman, did you know that the Nobel Prize not only comes with a cool statue and a plaque, but also $1 million cash prize.
I did know that. I've been trying to get my Nobel Prize for a long time.
I need one too.
So go Marie Curie,
Yay!
representing women in science.
Who doesn't like a smart lady?
Yes. All right, now let's do some changes. Life keeps changing. All right, we'll edit all that. Okay. All right, Miss Harder, we are going to start first with a chemical change. So we
What's
mentioned.
a chemical change?
Well, I was just about to explain, Miss Harder.
Okay, good.
I
Sorry,
can't-
I was pretending to be a grade 5 student who interrupted you all the time.
All right, we're going to do a chemical change. So a chemical change is when it changes not only in state, but also the properties. So if I burnt a piece of wood, it turns into ash. And it's very hard to get the ash back to wood.
Yeah, you never could.
Or if you fry an egg, it used to be all runny, and now it is a solid. So a chemical change is usually something that is very hard to reverse, or it can't be reversed.
Exactly.
And it usually gives off another substance. So I have this trusty bottle here, and I am going to fill it with some baking soda and some vinegar, and it is going to produce carbon dioxide.
Ooh, I can't wait to see.
Look, it's Zachariah!
Hi, Zachariah!
She's our special guest. No, just kidding. We can't.
Hey, Ellie!
How are you?
Good, how are you?
Oh, there's an ant!
What are you making a video for?
Classroom chemistry!
Can I make a special appearance?
Don't you have a funnel ball?
No, I don't.
What's wrong with you?
That's cool.
Nice! Good job, Zach.
Okay, we're gonna do this. Okay, balloon.
So in the bottle of science, there's baking soda.
Yes.
That's
Which-
this stuff. You might have seen it in your fridge or use it for baking.
Which is a base. Now we are going to add vinegar, which is an acid. Oh, I better get my balloon ready. It's harder.
Yeah, get your balloon. You could try this at home if you have the baking soda and the vinegars at your home. Do it either outside or in the sink, because your mommies or daddies will be very mad if you make a big mess.
And you need adult supervision and permission. As we are adults, we have given ourselves permission and are supervising ourselves and each
Yeah,
other.
unfortunately, Mr. Wilkinson did not give permission.
Also,
or
is there a
supervise.
bug on the lens?
No, I think it's fine.
Hey, Ant, get off the camera! All right, Miss Harder, I am going to pour the acidic vinegar into the basic baking soda, and I am going to put a balloon over it, and the balloon is going to fill up with carbon dioxide. Do you believe me?
Yes, but you should probably stretch the balloon first, otherwise it won't be able to do that. Yes, I do believe that's going to work.
Okay.
Pour it all. Be aggressive, and you gotta be fast, girl. Fast, fast, fast! Go, go, go! What is happening?
I don't know. This balloon is malfunctioning.
Well, it worked. It did definitely inflate it.
All right, there's our
What's happening?
carbon dioxide.
So, Fives, you'll notice that in the bottle, there was like lots of foaming and fizzing, and that's the reaction. When you add a base and an acid together, they react with one another, and they'll actually make neutral compounds. So when we're done, we should have 2 neutral compounds.
Ooh, let's test it with our litmus paper.
Well, you just threw it all in the grass.
It's all over the lid.
Just like to say fond farewell to the grade 6s. This is our way to go, grade 6 farewell balloon.
All right. What color is that, Miss Harder?
And white.
Well, it's off. I know it's hard to tell. It is off yellow, or it's a yellow green, so it is about a 7. So it became neutral.
Woohoo! Look at
And-
science working.
Yes. And we know it is a chemical reaction because it produced something else. So it produced some carbon dioxide. A liquid and a solid produced a gas. So now we are going to do a physical change. So we
Nice.
are going to mix a solid and a liquid, and usually it can be reversible. So it's only the state that's changing, not the properties.
Okay.
All right, Miss Harder, we're going to have to move this out of the way. Actually, we'll go this way.
You should be able to.
We all in the frame. We open the bottles first. Or should we do that on camera?
It is on camera.
It's filming right now.
Okay, so sizzle.
John's not aware of the process.
I have no idea.
Yeah, so if you put it, yeah, see, it'll be perfect. So,
I think you're gonna do that, and none of them are gonna go in there. Personally.
well, we're all gonna have to run.
Harder.
What?
You should
Mine's too fat.
put Mentos in, then put the lid back on.
Well, you put it upside down, Miss Harder, and then you just.
Yeah, and then you hold the
Mine
paper.
is too fat. Okay.
It'll
They're all
go,
the
it'll
same
go around
size.
Yeah, they're too fat. No, John has a
Okay.
skinny one.
Okay,
Are you ready, Miss Harder and
Yeah.
Mr. Haverson?
I guess so.
All right, we are mixing mint Mentos with Diet Coke. In 3, 2, 1. Now.
I need to do that. I like that.
That's an exciting physical change.
Smells like Coke out here.
Great twins.
Anybody thirsty?
No, I'm good.
And that's science. In the words of Bill Nye.
Science rules.